The next part of the lesson asks us to solve quadratics by completing the squares. So let's take a look at the first one. First step when completing the square is to move the 35 to the other side. So whenever you move something, all it does is switch signs because you have to do an opposite operation. So it becomes a negative 35 on that side. And so from that point, we're going to take this b term and we take half of it. So you take that 10 and divide it by 2 and you get 5. Well, that tells you right away, you know what the factored form is. It's going to be the two numbers that add to make 10 have to be x plus 5, or 5x and 5x. And so you're going to take that 5 and square it to figure out what it is you had to add to both sides to make that a perfect square trinomial. So that would be 25. And so on this side of the equal sign, you add these two terms together, and you end up with a negative 10. Well, we've got a problem, and you'll see it shortly. When we take the square root of both sides, we can't take the square root of a negative number and get real answers. And so what we say is that there are no solutions. And the reason is because we can't take the square root of a negative number in this class. So that's our answer there. Basically what that means is that this quadratic does not cross the x-axis. Taking a look at this next one here, same sort of thing. Got to move this 11 back to the other side. So we've got an x squared plus 8x equals negative 11. And then we're going to end up taking this 8 and we take half of it. And that makes 4. And that tells us what the factored form is. It's x plus 4 quantity squared. Well, you're going to take that 4 and square it to figure out what it is you have to add to both sides to make that. And that's a 16. So we end up having to add 16 to this side, and we already have the factored form of it. It's right here. And we add 16 to this side, add those two numbers together, and that's the number that goes on this side. So this all equals, and we'll put a 5 right here. And so from that point, we're just going to take the square root of both sides. And that will cancel out this little squared symbol, leaving us with that x plus 4. So x plus 4 equals plus or minus the square root of 5. And then from that point, all we're going to do is move that 4 to the other side by doing an opposite operation. And so when we write our answer, when we've got it in the exact form, when we leave it as the square root of 5, we can write it as x equals negative 4 plus or minus the square root of 5. So in order to approximate it, we'd have to take the square root of 5, which is somewhere in between 2 and 3, a little closer to 2 than it is to 3. And then from there, we would end up adding it to negative 4 and then subtracting that number from negative 4. And so let's take a look at the next one. First step, again, is to move that 4 back to the other side. So we're going to have a 2x squared plus 9x equals negative 4. Well, from that point, we need to get rid of this 2. We need to get rid of that coefficient in front of the x squared term and divide both sides by 2. So we're now left with this x squared plus 9 halves x equals negative 2. Well, from that point, we take half the b term. And so here's where the problem gets a little bit tricky because there's some fractions, but they work themselves out. So let's take a look at it. Half of 9 halves equals 9 fourths. And right away, you know what the factored form is. It's that x plus 9 fourths. And then from there, we have to take this 9 fourths and square that. And that'll tell us what we're adding to both sides. So that makes an 81 sixteenths. So we put a plus 81 sixteenths on this side, and we add it to this side as well. So up on the top of the page here, I'm going to go ahead and do some work. I'm going to come up with a common denominator. That's going to be 16. So negative 32 over 16 plus 81 over 16 is what I'm doing. So I need to subtract these numbers. 32 from 81, and that gives me I'm going to borrow here, change it to a 7, so I end up with a 4 and 9. So 49 is what I get, a perfect square. So this is going to work out fairly nice. So we end up with 49 sixteenths is the number we have there. And so when we go ahead and take that square root of both sides, cancel out the squared symbol, leaving us with this x plus 9 fourths equals plus or minus the square root of 49 sixteenths is 7 fourths. So at this stage, our denominators should be the same, and they are. If they're not, then you've done something wrong. So always check for that. So we subtract that 9 fourths from both sides, and we set up our two problems. So we have 7 fourths, take away 9 fourths, and we also have negative 7 fourths. So Let's fix that real quick. So we have negative 7/4. Take away 9/4. So when we do that work, we end up with 9/4. So we end up with negative 2/4, which makes negative 1/2. That's one of the answers. And then on this side, we have a negative 16/4, which makes negative 4. So there it is. Our negative 1/2, comma, negative 4. Those are the two x-intercepts. So looking at this one, we got one problem that deals with quadratics, but instead of a projectile, we have a geometric problem this time. So the rectangular room, so let's go ahead and sketch that in here. Rectangular room there has an area of 195 square feet. So A equals 195. Its width is 2 feet shorter than the length. So we'll call this the width since this side's shorter and this the length. And they gave us an expression for the width. They said the width, again, is 2 feet shorter than the length. So we'll go L minus 2. Find the dimensions of the room, round to the nearest hundredth of a foot. So when we do this, our area formula is length times by width. So let's go ahead and substitute some material in there. We've got 195 for the area. The length, well, we don't know what that is, but in place of W, let's put this expression, L minus 2. Let's go ahead and use the distributive property there. So 195 equals L squared minus 2L. And it's all set up for completing the square, so let's go ahead and use that method. So we're going to take half of this term, and half of negative 2 is going to end up equaling negative 1. So we take that negative 1 and square it, and that gives us 1. And so we end up having to add 1 to both sides. So we've got the factored form here. It's going to be a x minus 1, because negative 1 plus negative 1 make the negative 2, and they multiply to make a positive 1, equals 196. And so from that point, we take the square root of both sides. So the square root of 196. And we take the square root of that expression there. So, and we end up seeing what we end up coming up with here. So when we take the square root of 196, well, that's a perfect square, and that makes 14. Now, if it wasn't a perfect square, we would end up having to approximate it because we do want to find out what this dimension is. So 196 is a perfect square, it makes 14. So x minus 1 equals plus or minus 14. So from this point, I have to add this 1 to both sides, and I can come up with my two values. So I have a 14 plus 1 equals one of the values of x, and the other one's going to be negative 14 plus 1, which can come up with another value. So let's go ahead and write down what those two numbers are and talk about them. So we'll go ahead and write down the 15 is 14 plus 1, and on this other side, negative 13. Well, can you have a negative number being a distance? No, so that's not the value of x, or in this case, x, I should have used L instead of that, because that was L. Let's go ahead and change it real quick. So the length is going to end up being 15. So 15 feet is our length. So I'll squeeze in those units there. And how about the width? Well, the width is L minus 2. So it just happens to be the opposite of that number. So width equals L, but in place of L, I put 15 minus 2 gives me 13. So there it is, 13 feet. So 13 for the width and 15 for the length. Well, those are some of the problems you'll see on tonight's homework. Good luck.